All right, this lesson's basically the culmination of Unit 1. So we've extended the domain of trig ratios, so now we can do all real numbers. We learned about radians and converting to radians. We learned about evaluating it using coterminal and reference angles. We learned about inverse, evaluating inverse trig functions, and now compound trig expressions basically combines all of that all together. So if you're able to do this, especially if you're able to do this without a chart or referring to anything, you basically have mastered Unit 1. Ideally at this point, you know a lot of these numbers off the top of your head. Some of them, you know, usually tangent, cosecant, secant, and cotangent. It's nice to have a table to reference, but you should be able to create any of these materials on your own. You know, if you had a blank chart and a blank sign chart and a blank absolute value chart, you should be able to fill all this in on your own and then be able to refer to it. Sometimes it's easier if you're working a lot of problems or if you're on a test, it's easier to work out, you know, all of it once and put it in a chart and refer to it than it is to work it out every single time. So I'm going to be using the charts that we did in previous tutorials as reference, but ideally, again, you should know where these numbers are coming from. This shouldn't just be out of the blue. All right, so what we mean by compound trig expressions is they are compounded within one another, basically a composite function. So we could say, what is, you know, sine of the inverse tangent of 1? All right, essentially you're finding the sine of the angle that has a tangent of 1. All right, so if I did the inverse tangent of 1, if I just by looking off the chart, that's 45 degrees or pi over 4. So this is really saying sine of pi over 4. And then I look at the chart and the sine of pi over 4 is root 2 over 2. And again, the angle that the sine of the angle that has a tangent of 1 is pi over 4, right? So if you look at pi over 4, it both has 1 as a tangent and root 2 over 2 as its sine. All right, we could also flip that. So maybe if I have it on the outside, right? If the inverse is on the outside, then we know that we should be getting an angle as your final output. Let's do something trickier. So cosecant. And we'll do the cosecant of 90 degrees, so pi over 2. All right. So first thing I'd look at is the cosecant of pi over 2, which is 1. So I'd be doing the inverse tangent of 1, which is pi over 4. So now the angle is actually switching. And so this is a little bit more difficult when you have the inverse on the outside because now it's actually switching things. All right, also we'll look at situations when we're doing non-unit circle values, kind of like we did in the second lesson we were looking at. If they give you one trig ratio, if it's not a unit circle, how can you find other trig ratios without actually finding the angle? All right, for the heck of it, let's just do 3 of them at the same time. So I'm going to take the sine of the inverse cosine, which is taking it of the tangent of pi over 4. So tangent of pi over 4 is 1. All right, so I'm still taking the sine. Whoops. Actually, this will work. Sine of inverse cosine of 1. Well, the inverse cosine of 1 is just 0. So I'm taking the sine of 0, and the sine of 0 is 0. All right, we can do in similar fashion. We could have the inverse starting it. So inverse cosine of the sine of I don't know, 11 pi over 6. So the sine of 11 pi over 6, well, 11 pi over 6 is in the fourth quadrant. Its reference angle is pi over 6. So it's the inverse cosine of a negative 1/2. Well, negative 1/2, or 1/2 for cosine is 60 degrees, but we're going for the second quadrant angle. So it'd be 120 degrees, or 2 pi over 3. All right, remember, cosine has a range between 0 and pi. All right, so when you're doing the inverse cosine of a negative, you don't get a negative out. All right, and we'll see for sine and tangent, you will get a negative out. All right, so if I do the inverse sine of negative pi over 3, well, for pi over 3, excuse me, try to get the output. So let's just say negative 1/2. All right, so for 1/2, that's usually 30 degrees. So this would be negative 30 degrees or negative pi over 6. All right, so I'm able to refer to the list directly. Whereas for cosine, when I refer to it, I have to think of the second quadrant angle. So it's easy because I just got to add a negative for sine or tangent. All right, another situation you might run into is if it's not a unit circle value. So I want to find the sine of the inverse cosine of, I don't know, 3 over 7. All right, this is where you'd have to diagram it. All right, so that'd be 3, that would be 7. I need to find this side. So it would be a squared plus 3 squared equals 7 squared. A squared plus 9 equals 49. A squared equals 40. A is the square root of 40, which you could say is 2 root 10. All right, so then the inverse sine usually gives me an angle, right? Which we're just calling theta. So really I just want sine of theta. So I want the sine that's in this triangle. So that's 2 root 10, and that's the opposite over hypotenuse, which is 7. Right, so I've never actually had to find the angle. So this can only really work as a compound when they have it on the outside, because you'll never find the angle without a calculator. So that's a situation you might run into, and you'd have to diagram it. Again, this is the culmination of everything that's done in Unit 1. All right, so those are a few examples. I'll probably also post some tutorials just going over some specific problems. This is basically for those that are learning it for the first time, or if you've completely missed the boat and you missed a day, or you just never understood it the first time. It's basically a lesson as opposed to just working problems. All right, this will conclude Unit 1. And if you have any questions, you can always contact me.